Are you struggling with Wordle but don't want to cheat? Well, I certainly do, so I've taken matters into my own hands. Now, I've commenced on a mathematical journey which will hopefully help you become the best Wordle player you can be using maths. And I'm going to document it along the way. If you've clicked on this video, then you probably already know the Wordle rules, but we're going to speed run through it just in case. 5-letter word, 6 goes to do it in. Green is the right letter in the right spot. Yellow is the right letter in the wrong spot. Grey is not in the word at all. The big question is, what is the probability that you get the word correct on your first try? Well, there's 26 letters in the alphabet and 5 letters for each slot, so you might think getting it right on the first try would be 1 in 26 to the 5, which is a tiny chance, almost like trying to pick a random person from the population of Burundi. Intuitively, we know this isn't correct, as we couldn't type or get a solution of 5 A's or 5 B's, for example. And to emphasize this, I made a random 5-letter word generator on MATLAB, although these aren't words at all. In fact, Wordle has its own list of 2,315 possible solutions, and a separate list of just under 13,000 allowed words, which are just words the game accepts but can't be correct. Since Wordle has 2,315 possible solutions, the probability of guessing correctly on the first try is, well, 1 over 2,315. If you're not sure what word to start with, or you're bored with your usual guesses, you can try adjusting the random 5-letter word generator to other lists and actually get words that exist in the game. Although the bigger question is, what is mathematically the best starting word? We all have favourite words that we like to start with on Wordle, but you can actually use maths and letter frequencies to help. So we know every 5-letter word in the English dictionary, in fact every word, contains a vowel or a Y, so you may want to choose a word with lots of vowels. One such as adieu, which according to wordplay.com is the 3020th best first word, whereas audio is the 6105th. Now this is the bit where I start to really ruin the game for myself, because I've seen these numerous websites that will tell you the best first word and the ranking of your word, but they don't really tell you the mathematical basis, and if they do, it's quite complicated. And I'm not a great mathematician, so I kind of wanted to just start from scratch and find quite a simplified way of finding this. So because I wanted to ruin the game even more, I made this code called letters, which counts the number of letters within your list and outputs the order of frequency. Now all that means is it just gives you the most common letters from left to right, E being the highest, frequency, J being the least in the possible, and S being the most common out of all the words that you can put, which is strange, being only 8th on the possible list. Now filtering through a word like a rose springs out straight away, which intuitively is quite a good word. It's got 3 vowels, it's got the 2 most common consonants in Wordle, but this code doesn't tell us anything about order. So, like an E is the most common, but you wouldn't have it in each of the 5 slots, for example, So to solve this problem, I adjusted our code so that it outputs the 5 most common letters for each of the 5 slots using our letters code column by column. Now this sounds confusing, but here the first column, for example, shows the 5 most common first letters, so S being the most common, and filtering through column by column, a word like crane pops out quite high up on the list, which I know a lot of people like to use, and according to our trustworthy wordplay.com, ranks as 20th. So just a bit of simple maths and letter frequencies, we can find a really good word to start with on Wordle. Now to repeat this again, but for all of the words, I found what I thought was an excellent first word to use, which Wordle disagreed with, unfortunately, and yes, I tried. But perhaps a better word on here is boras, which apparently is the plural of bora, which is some kind of wind in the upper Adriatic, which you might know if you're from maybe one of these countries. At this point, even though the maths is very simple, I haven't really been able to test or prove anything that I've claimed. So I want to make a maths Wordle solver on MATLAB where you input your previous guess, where the green letters are uppercase, the yellow ones you put lowercase, and then the grey ones you put question mark, and try and see if we can reduce scores that way. Finally, after weeks, I've managed to finish my Wordle solver. It pretty much works. I mean, I'm not great at coding, so anyone who hates inefficiency in their codes, look away now, because this sucks, but it doesn't matter because I wanted to keep it simple. I wanted to tackle Wordle's hard mode using maths, as that's the way I've always played the game, and to be honest, despite being hard mode, it's actually a lot easier to code, because any revealed hints, i.e. your yellow letters, your green letters, they must be used in your subsequent guesses. So it makes it a lot easier to code, and it will reduce your list significantly. So let's say we had our first word as maths, and this is what we got. Then we would input this. Now I had it saved already because it takes a long time to type out. But so we have our grey letters, yeah. MTH, and A is our yellow letter. S is a capital because it's green. And look, we've reduced 2,315 words to just 6. Now from here, you could just, guess because there's only 6 and think about the frequencies and things like this. Or you could randomize it. Now it comes out as class, but thinking back about the frequencies in each slot, I'd be inclined to go for crass as my guess, because C is the second most common first letter and R is the third most common second letter. So if we were to do that, even though it's quite an odd guess, we would get this. Alright, so it's nearly there. We can work out that it's either going to be grass or brass. But if we were to put it in our solver and put C, add C to the list of letters that don't exist, yeah, we have brass or grass. Now, thinking back about our letter frequencies in general, we see that G is actually more common than B overall. But we see again that B is actually the third most common first letter, more common than G, because G is not even on here. So I'd be inclined to go for brass as my guess. And yeah, in fact, that's the answer, sorry. So in 3 guesses, we have managed to reduce what was a list of 2,315 words to 6, to 2, and then finally to 1. So I decided to test my code by playing 20 games of Wordle using Crane as the first guess and randomizing most of my next guesses. Now, I understand that statistically, 20 iterations isn't very significant, but I managed to get a mean of 3.65, which I thought was pretty good, seeing that the best country in the world at Wordle is Sweden with 3.72 as their average score. So if I can beat the Swedes, then, well, my job is done. Except it's not. Well, I've realised just now that you can't find an optimal average score by just taking into account the first word. You're going to have to take into account the subsequent guesses, and there's probably some words which aren't as statistically strong to start with, which with a combination of subsequent guesses will give you a better average score overall, which goes into a little bit on information theory, which I'm going to have to research a little bit about. So let's go into information theory, but keep it very simple. A nice inspiration we'll like to think about is communication. So us humans, we communicate verbally and physically, as do animals and even computers. Now this is more generally just a way of sharing information, and this information can be quantified by a measurement known as entropy. This concept was introduced by an American mathematician called Claude Shannon in 1948 when he created the following formula. Now this looks really complicated, so let's just scrap this for now and think about it logically. Now let's look back at an earlier example we had where maths was our first guess and we reduced the list of possible solutions to just 6. So here we received a high amount of information, as the probability of filtering out so many unwanted words was so low. However, this doesn't mean that the word maths is necessarily a great first word. For example, if we got this, it wouldn't be as helpful, as we only reduced the number of words to 120. Now I know that 120 seems significantly smaller than 2,315, but compared to that 6 we had before, it does seem like a huge difference. Now recall that after each guess, each letter will be either green, yellow or grey, so there are 3 possible colours, 5 letters in each word, so there are at most 3 to the 5 possible combination of colour patterns. Now remembering this, to find out the average information we get from the word maths, we would need to calculate how surprising each result would be, and take the mean of it. Now, what I really mean by the word surprising is, well, how low the probability is of the pattern occurring, i.e. how high the amount of information produced is. Of course, we can optimize our subsequent guesses on hard mode using a lot of inspiration from information theory. So after a guess, we can look at the probabilities of each letter of the alphabet appearing in each slot. So we notice C has a high chance of being the first letter, which agrees with what we found earlier when looking at letter frequencies. I then wrote this terrible sentence which basically says we want to find the word with the largest sum of its 5-column probabilities from the list of refined possible solutions. So basically the filtered list we got of possible answers from our previous guess. So let's use the example with crane as the first guess with this result, and let W be the 5-letter Wordle answer. Now we can make some quick observations which were very useful when making the solver for me. Well, firstly, the probabilities of the first letter of W being C and the second letter of W being R are both 0, as they're grey. Then the probability of the 5th letter of W being E is 1, so the probability of it not being E is 0, as it's green. But the more interesting thing to think about is what happens to the yellow letters. Well, A can't be in the 3rd slot, so it must be in the 1st, 2nd or 4th, so we want to find one of those slots with the highest probability, and look at the words with A in those slots, and similarly for N. So let's use MATLAB to help. I made code info, which gives the probability of a letter appearing in each slot of W from a given list. So from our previous example with crane, we would get one of these words to be our possible answers. Now, because there's only 6 possible answers, it's really easy to spot what's happening. But if we were to use our info code on this list, for yellow letter A, it shows clearly that the highest probability is 2/3, and that's in the 1st slot. And then repeating this for N, it's obvious to see, 2/3 is the highest probability in the 2nd slot. So we would expect the first letter of W to be A and the second letter of W to be N. Now, because this is hard mode I'm focusing on, it's very tricky to guess one of the 4 words with AN at the start. So we want to solve this more rigorously. So from the refined list containing X words, or 6 in this case, for letters 1 to 5, we want to compute this info of each slot, sum up the probabilities in each column, and then choose the row with the maximum value. So using this code on the list guess 2, we actually get 3 words that come out. Now this is because the I in the 3rd slot appears an equal number of times as the L in the 4th slot. So I've altered my code now so that if the length of the output, i.e. the number of outputs, is more than 1, it runs the code again, but applying these words and the probabilities of each letter appearing in each slot, but over the whole domain of possible words. So in this case, we would get the word anime to be the answer. And now if we were to use this word as our second guess, we actually get it correct. So we were really lucky and managed to get it in 2 goes using this code. Now that I've made this optimum code, I've found that if you input from the list of possible answers, you actually get slate as the best word, supposedly. And from the list of allowed words, soars is the best word. Finally, the research is over, and we can all beat Wordle using maths now. Except, I'm still not sure whether crane is the best first word or slate, but what I do know for certain is that I can't say the word
subsequent.
And I'm actually never going to play Wordle ever again. Thank you for watching. This video was made for a University of Bath project, and I would greatly appreciate if anyone could leave their feedback. Thank you very much.